All right, so this video is going to be quite interesting, all right? So this video, we're going to be stepping back into the definite integrals, right? Into definite integrals. But in this video, we're going to be doing an example that's quite interesting. So let's say we wanted to evaluate the definite integral at the two bounds of integration 1 and 1. That's right, the lower bound and the upper bound are equal. So what's going to happen? You can probably predict this, right? What's going to happen? But we'll see what'll happen when we evaluate this. So let's do this for the function 2x dx. So again, let's go back into the evaluating the definite integral. And so if you don't know how to do this, I'd encourage you to go and watch the previous video that I made on evaluating definite integrals. So let's first find the antiderivative of this. Again, that's going to be 2x squared over 2, and the 2's cancel out, and this is just going to be x squared. If you don't know what I did, again, go review the rules that I went over for, the reverse power rule, the constant multiple rule for integration. So this is just going to be x squared. And technically, we do need to add this plus c over here, but I won't add it because, as you will see, when we do the subtraction, the plus c will and the other plus c will cancel out, so we don't need to add it. And this will be evaluated at 1 and 1. And so now let's take this 1 and put it in as for x. This is going to be 1 squared minus, again, 1 squared. Now you probably know what this will be equal to. This is basically equal to, what do we have when a number minus the same number is subtracted? Well, we have 0. That's exactly what this is going to be equal to. 1 minus 1, 0. So that's interesting, right? So we see that when we evaluated it, when we evaluated a definite integral, and the lower bound and the upper bound of integration were equal, we got, for some function, we got 0. So let's do this with one more example, see if we still get 0, all right? So that was a weird sign. Let's go back there, and let's do that. The definite integral evaluated, let's do 2, right? Let's do lower bound and upper bound equal to 2. For the function, let's do 3/5 cosine x dx. What is this going to be equal to? Well, same thing. We can find the antiderivative of this, and this is going to involve the trig functions, right? The antiderivative of trig functions. So there's going to be 3/5 times, what is the antiderivative of cosine x? That's going to be sine x. And we don't need to add the plus c, as I explained before. It will be canceled out, so we don't need to add it. Let's evaluate this at 2 and 2. So again, plug in the 2, 3/5 times sine of 2 minus 3/5 times sine of 2 once again. So sine 2, sine 2. Again, we have something minus the same thing. This will just be equal to 0. 0. So again, the same pattern emerged, and this was kind of expected, right? Of course, the same pattern will emerge. So let's write out a general rule for this. So I'm going to scroll a little down, and I'm going to write out a general rule for this. So if we have the definite integral evaluated at a, right? So a, both these, this is the lower bound, this is the upper bound, both of them are equal. For the function f of x dx, this will always be equal to 0. All right? This is an important rule. Let me box this in. This is important. This is important to remember and to realize that this is the case. So whenever you have like a complex problem, right? And we'll be going over some examples in the next videos where we have the equal, right? The lower bound and the upper bound of integration are equal. Always know that that's equal to 0. We don't even need to evaluate it the way I did. Like I found the the antiderivatives, and I did all these steps. You don't even need to do that. You can just directly jump to this step and just set them equal to 0. So I hope you found this video helpful.